Alright, so now that we planned out our project, we planned out this UART controlled dimmable LED. What I want to do is show you how to begin merging example codes to get what you want. So to do that, I still have our two examples over here. I have this the timer example that's controlling the LED, and I have the UART example that we did previously, and I have both of their C files open, ready to go for whatever we need to look at. So if I'm going to start a new project, you know what? Let's actually create a new project and go through that activity. So I'm going to click New Project, and there's a couple of important things that you're really going to have to go through here. So I actually will start typing in our target, which is the MSP430 G2553. And it should really help narrow down that device. It picks what connection we want to use. We give it the project name. Let me call this UART LED example. Sure, why not? If you want to mess with your compiler versions, you can do that. Here's kind of the main thing. You can pick one of these other examples here if you want. So you could do an assembly-only project, the RTSC project. We're going to pick empty project with a main.c file. I like that. And then we're going to go ahead and hit finish. And now we have a brand new project that if we expand it, it has the includes, the debug, the target configs, all this fun stuff. But if we look at it, we have a main.c file. And if you look, this is all that it gives us. It gives us the MSP430 header file, tells us to stop the watchdog timer, and a nice return 0. And this is where a lot of you, I think, are going to be a little stumped as to where to go from here. So I'm going to tell you right now that something I personally really like to do in general. I'm not going to do it in this one. I'll show you another way to approach this in another video when I get a little bit of sleep in me and I remember how to do a bunch of C stuff. One of the things that I personally really like doing when I'm writing this code, any sort of programming code, is it really helps my mindset of like, how do I want to approach this, is most of the times, again, I'll show you this in another video, is just like we did when we did our example. I will actually have functions in the beginning of my main file that are called like timer setup. Maybe I'll use camel case here, timer setup. And it'll be a function that you just run. And then GPIO setup. And I'll make a bunch of these setup functions so that way I can encapsulate what's going to happen with each one of these, and it's very easy to then debug or go back and change settings. So instead of doing that now, I want to do it the way that you all are probably going to start, and you're going to see real quick why that's something that I kind of tend towards, because this becomes very nasty looking very quickly and very hard to understand what's going on. And that's the key to all of this, is being able to understand what your code is actually trying to do. So here's what I'm going to do. First and foremost, I'm going to come into my example. Now, yes, you all should actually copy the copyright because you're using the example code and things like that. But that being said, let's just get the main things in here. So let me look at my LED blinking. So if I look at it, I come down here, and I need to look at this very carefully. So I need to take and set up my pins. Now let me change the comments here. I didn't save it for my last time, but this is actually we're actually changing to pin 1.6 for all of this stuff. So here's what I'm going to do. I'm going to come up, and if you try to copy the whole main function and paste it, y'all are in for a world of hurt. What you should be really doing, and this comes back to really taking a hot second to look at this code and see what it's actually configuring so you know what to take. So for example, I don't need to copy the whole main function. Let me take the port configuring so I know which way the pins are going. Let me take the timer configuration stuff, and that should be good. Now look, it looks like the whole thing, right? But ideally I'm going through here and seeing, okay, this is what I need to run my PWM. I'm going to come back to main.c, and I'm going to pop it in here. And hey, look, all the commenting came with it. Just be careful sometimes with all the indenting. It's does C++ or C really matter with indenting? No, but some of you are going to get really crazy if I don't line up my indents. But guess what? It's too late at night for me to do this, to care. Okay, so this one was an easy one to follow. This one, not so much if you're just going to copy and paste. So we have this calibration thing here. Do we need it? I'll say sure. The reason is you should look at what this does, but we're trying to do a 1 megahertz clock to run our UART. And it would be really nice to know that that's actually going to be 1 megahertz, because otherwise we're not going to be able to read any data. So I actually would argue that this is extremely important to do this calibration step. Again, how do I know that? Well, I've done this a couple times, and you should really look up stuff. Don't take this as like, yes, every time I start up my project, I'm going to need to do this. No, you should really know whether or not what you're doing, why you're doing it, if you need to do it. So, okay, that takes care of my calibration. Cool. So now if I look, well, I'm also doing port selects here. So P1 selects and all this fun stuff. So great. That looks cool. Let me pop that in here. I'm only doing the enters here because I'm doing it in phases. Again, white space doesn't really matter. All right, cool. I'm setting up my UART peripheral right here. And I'm setting up so that it can be interrupted, all that fun stuff. All right, cool. Let me copy all that. Grab that in here. And again, if I actually was doing my due diligence, right, what I should be doing here is commenting. So I should be saying something like, calibrating submain clock or SM clock. And then I should come down here and say like, I should say, let's see, configuring. So let's see, we can do a configure UART pins. Cool. And then down here we have, let's see, let's put another enter here. Configuring UART peripheral. Look, I'm taking these extra 2 seconds, but look at how readable and how, well, spelling errors aside, how much easier it is now to understand what each one of these are doing instead of just copy, pasting, go, and then all of a sudden your thing doesn't work and you're like, I'm staring at a bunch of words, I don't know what they mean, and I don't know what they're doing for me. So configuring the UART peripheral, cool. And then I'm going to come down here and say maybe, I don't know, let's do the configure LED pin. And then maybe down here I will say configure, or I should have done an enter. Configure timer, or timer A0. Cool. Now I'm going to get rid of this return 0. I don't really want the return 0 there. So that's all my setup here. So I'm setting everything up initially for my processor to run. Now if I go back to my PWM code, it says, well, go ahead and enter low power mode 0 where the CPU isn't doing anything. You could also achieve this with a while 1 loop. It just will burn CPU power. This just lets it turn off, but you know what's interesting? This one says just CPU off. This one says something different. It says, well, let's go to low power mode, but we're doing this weird GIE thing. So GIE is the global interrupt enable. If you do not toggle this bit before your controller goes to sleep, no interrupt is going to wake it up. So to me, I look at this and say, well, if both of these are trying to go to low power mode 0, which this is, I'll pick this one as my sort of like, what do I want it to do? And it fits back to our previous sketch of like, let's enter low power mode 0 and it'll just sit there. It is your job as the designer though. Please, big disclaimer here. Again, none of this is like, don't come back to this and think, yes, I need to create PWM, so clearly I'm going to come back to this video and reference it. No, this is not really meant for that. This is just showing you one way to do it. And in fact, you should look at what the low power modes do and ensure that they maintain what you actually want to do. In certain low power modes, certain peripherals get turned off, certain timers and certain clocks get turned off. So you really want to make sure that you're actually following along. I just know for this case that looking around, things are probably going to work out for us, but we'll see. Okay. We've entered low power mode 0. Now we have to deal with our ISR, so our interrupt service routine. It's all of this. Now, I didn't go over this before, but very quickly, I'm going to go over what this interrupt service routine is doing. First and foremost, notice that it's outside of our main loop, which means that this is something completely different. So the interrupt service routine is basically, at the end of the day, what really matters here. All of these define things are trying to ask the compiler, hey, what version of the compiler are you using? If you're using this one, I know that I need to use this format for my interrupt routines. So for example, if we're using the TI compiler, we need to use this to declare an interrupt. If we're using the GNU compiler, we need to set this as our interrupt. Otherwise, tell our user that, hey, the compiler's not supported and it won't compile. Our actual routine is just this. What routine is it? It's going to be the RX vector. So it's going to be whenever we receive a byte on USCII A, we're going to set off this interrupt, and under the hood a little bit, what it does is it basically what we're creating here is like a function pointer. So what happens is it says, hey, this interrupt went off. Load this function onto the stack and run it. So that's a lot of comp arc stuff, but basically, yeah, every time that our interrupt fires, it's going to come down here and do something. Now this is where things get a little interesting, right? So we said before that we wanted a case statement. So I'm going to do a simple one, and I actually want you all to, I'm going to do if statements. And I want you all to look at expanding it. So I'm just going to do a couple levels, like 0, 1, and 2. Like maybe that'll be 1/3, 2/3, and full. So here's what I want to be careful of. Do I want to keep this repeat in here? Sure, I'll make the echo happen. It'll let me know that it actually did something. So this while loop is just making sure that it's able to transmit. Here's what I can do. This may not be the most efficient thing in the world to do this, but you know what? I'm just going to do it anyway. I'm going to make a variable called int x. Because our int received value is equal to UCA0 RX buff. Now here's the problem. I believe as soon as I do this, as soon as you receive or access the receive buffer, you got to look at the data sheet. You got to see if when you access a buffer, whether or not it actually empties. Some do, some don't. So I'm going to say this is storing the received byte. Even when it's like something even as simple as this, I like using I like using comments very, very often. That's the word I'm looking for. So here's what I want to do. If, and I believe it's been a while since I've done some C syntax. I'm sorry if this doesn't compile correctly, but whatever. If received, if I can spell right, if received value is equal to the character 0, then I want to take and set my CCR1 value, right? CCR1 is equal to, let's set my, we got to go back and do this. I want to do something simple. So let's say I do it from 900. Sure. So if I want 0, I want it to be off. So let's do 0. Or make it 1. Or 0. Cool. Else if received value is equal to 1, and of course I spelled it wrong again. I'm never going to spell it right in my life. Then I'm going to do CCR1 is equal to, if it was 900, let's do 300. and then else if. I program in too many different languages at one time, and I always get confused. Is it if, else if? Is it elif? What's my syntax here? So I'm not going to lie. If you ever ask me for help sometimes in C, I might have to look up some basic C syntax. It's one of the many languages we have to bounce around in. If it's 2, let me set it, CCR1 is equal to 600. Else if received value is equal to 3, make that CCR1 is equal to 900. Sure, full on. Cool. And then what I'm going to do here is just to really, you know what, I'm going to leave it as RxBuff. Let's see what happens. So I'm pretty sure I coded that correctly. We'll see in a second if my C code is correct. But the idea here is that based on the input, set the CCR value to a given thing. Now, there's going to be a lot of you that are probably sitting there from, especially I see this a lot from people who are used to high-level languages and never had to really do resource-restricted computing. You may sit here and say, well, that seems like the long-winded way. We were taught in CS, try to come up with an algorithm, and you're good. Like, try to come up with something simpler. So for those of you, astute of you, would see this is, well, clearly, this is better suited if I just wrote it as CCR1 is equal to my received value translated from ASCII into, or times 300. So what I mean by that, let 0 get translated to the number 0, and then it's going to be 0 times 300, which is equal to 0. That would work. 100% that would work. The thing is that takes clock cycles. Multiplication takes clock cycles. Converting from a character, which is just, hex values or binary, and shifting it, yes, it's subtraction, it just takes 1 or 2 clock cycles. It still takes more clock cycles. Something like this or a case statement could actually be more efficient. Will it work? Probably. But one of the big things about interrupts is you kind of want to get in and out as quickly as possible. So I'm kind of leaning on a few things here to program this, but doing this isn't necessarily inefficient. This actually could be quite efficient depending on what's going on. So my final touches here, if I want it to run from 0 to 900, I need to make sure that I actually set this to 900. And maybe initially I want it to be set to half brightness. Sure. So now I kind of wrote our code out. So again, if you look at it, let's calibrate our clock, configure the UART pins, configure the UART peripheral, configure the LED pins, configure the timer, and then let the CPU turn off and wait for an interrupt. Then, when we receive an interrupt, check to see what value we received. If it's a 0, 1, 2, or 3, do something based on that. Else, don't worry about it. You can make an else statement where it's like it turns off the LED, or you could try to print back to the user like, hey, be like, hey, I got a wrong value, try again. But seeing that we're getting around to the 18-minute mark on this, or 19-minute mark on this video, I want to see if what I even wrote will compile. I don't even know if it's valid C code at this point. Let's be honest, I'm just that tired. Cool, there's errors that exist. What's up with that? So we have a remark. We got some warnings and we got an error here. So all of these warnings are saying these operand types are not compatible. We'll worry about that in a second. So I can double click on this and it highlights, well, what is it expecting? Warning, warning, warning. What about line 75? Now, this is the thing that for those of you debugging, you may not catch this immediately for the first time, but if you look at it, it said there's an error at line 75. And it said expected a semicolon. And you may go, well, there's a semicolon there. What this means is that basically it saw something. It saw like 2 commands. Let's see, like an else if or something like that. And it expected before it sees a while to see the semicolon again. So don't freak out and say like, well, the semicolon's there. Work your way backwards. So start kind of where it tells you where the error is and work backwards. And if you look, I didn't do this on purpose. I slipped up. I forgot to do that. And now look, all of these things turned blue. It's happy now. So let me refresh the debug again. Hit OK. And I think we went through. And now I've got a bunch of warnings. So I've got warnings here. Operand types are incompatible. Int and char. So this is what you have to be very careful with. Your code will compile. What did it just compile, though? If it just said these are incompatible, what did it just do? So let's run this and see what happens. So I'm going to run this code. I'm going to come back to Scopy here. And I'm going to run. And I'm running at 50% PWM. Cool. I'm going to go to my pattern generator. And instead of sending 1, 2, 3, I want to send a 1 or a 0. Run. And if I go to the oscilloscope, it's still doing the same thing. So what I'm going to do here is I'm going to double check what pin everything's connected to. It looks like we are on pin, let's do my settings here. Digital IO 0. Sorry you're not seeing this on screen, but digital IO 0 is hooked into the receive line. Transmit is on 1. If I go to the logic analyzer and I clear this, that would be cool. Let me clear it real quick. I know one of the fast ways to do it is just go to the settings and like, hey, it's running. If I just do run, let me make my delay 33. There we go. Sure. If I go to my pattern generator and I send it, what do I get back? Nothing. Interesting. So I get nothing back. So what's happening in my processor? Well, something's clearly wrong. I'm still outputting a 50% PWM, but now it's not turning off. So here's what I'm going to do. And this is the power, by the way, of having a scope in front of you, whether that's in the lab or not. You should be able to actually see this. And in fact, if I really wanted to really show off what's going on here, maybe I'll also turn on channel 2. And I'm going to hook up channel 2. Channel 2's ground is going to go to, or channel 2's reference is going to go to ground. Let me not short 5 volts in ground and ruin this board and turn off the USB port. I'm actually going to look at the transmit line coming from my processor. Okay, so right now it's being held at a logic high. I want to take my, I'm going to turn off the pattern logic analyzer. I'm going to drag the pattern generator out. And I want to see what happens if I send something. Nothing. So my UART isn't responding. How do I know that? Well, again, the power of a scope. I can see that my UART isn't changing. And if I really wanted to, let me change it to channel 2. And I will do falling edge trigger. And I will do it. Let me move this up here. I will move my trigger to be here. And I'm going to set it to normal mode. So it'll just capture and hold whatever it sees. So I'm going to come back here. Something's not working. So don't sit here and say, well, that's cool. Something really isn't working now. Let me reopen my debug session. That's cool. I love when that happens. Awesome. Let me run it. Let me go over here. Go to my pattern generator. Where did my pattern generator go? There it is. If I hit single, nothing happens. If I hit pause, interesting. So it's just sitting here doing nothing. Almost like it didn't receive it. So let's start the debugging process. So what's going on? Well, apparently it seems like it's not even getting my my character. So here's what I'm gonna do. Well, you know what? Let me know if I'm even getting it. So if I want to know if I'm receiving something over UART, let me set a breakpoint here. So it's actually going to halt the code, and it will let me know if it actually sees something. So I'm going to hit go. I'm going to come back over here, and I'm going to try sending a 0. And we're here. Cool. I'm also going to show you how you can track certain things here. So I'm going to open up variables. Received value. It's received a null character. So I'm going to hit next. So two things here. Here's my variable received value. Excuse me. And here's my registers. So I want to check to see what happens after this statement. So I'm going to go to UART. OSCI A. I'm going to go to UART. I'm going to go to my receive buffer. And I want to check this. So I'm going to hit next. So interesting. It received 30, which if I look at an ASCII table, I'm going to tell you is character 0. If I go to my variables here, it received a value, decimal value 48, which is the character 0. Cool. And then it's going to see if received value is equal to this, which it should then jump down here. So I'm going to hit next. There's my problem. Again, I'm not like creating this problem purposefully. This is literally me coding on the fly. So what it is me not remembering my C programming. So what it is that, again, maybe I should like rewind here. Where's my jump back button? There used to be a rewind button. Where did it used to go? I am blind. No, I don't want to do assembly step. I would ask in class at this point, does someone see where to do a reset? But I don't see it. So, oh, there we go. So this button here is a restart. So what it does is it goes, all right, I'm going to reset the processor. We're going to go up. We're going to go bloop, and come back up here. Get rid of this boot C. I want to restart again just to catch what I just showed you. So I'm going to start. Come over here. Send a UART thing. So we go into the interrupt routine. And it received a 48 before. So let me step. Hey, look, we still received a 0. This check is happening. This next, when I hit next, should change this CCR value to 0. So meaning you should literally see it jump to execution here and then exit. Well, that's not what happens. It continues to check and then it fails. Doesn't find anything, so it doesn't do anything. So that means we got to fix something. Sometimes the errors, the warnings actually tell you something. So if we take a look at what this error was telling us, is int and char star. So star is a pointer. So here's the problem. I use double quotes. So Code Composer is interpreting that as me trying to say, I want to use a string. And if I want to use a string of characters, well, technically that's a character array with a pointer. So I've said received value is basically just an int. I've declared it up here as an int. So there's a couple things I could do. I could turn this into a pointer, a char, or I could come here and use single quotes. See, this is where night mode sometimes makes this very difficult. So again, for those of you who may not understand the issue there is a major difference between C++ and C when it comes to actually like getting characters and certain things interpreted. So here we go. Let's see if this works. Again, on the fly. I'm not pulling up Google. You all should normally just Google it at that point and say like, how do I do characters instead of strings in C? Don't be stubborn like me right now and not wanting to literally Google it. All right, so we're loading in. Let me keep my breakpoint here. Sometimes it keeps it there. All right, cool. Let's see if this works. So I'm going to run it. Come over here. Send my 0. And now I want to check. Okay, my variable is that. If I step forward, look what happens. My check passed. Now look what's going to happen. If I go to my registers and I check my timer, timer A0, CCR0 right now is hex 384. This is 450 in decimal. That's what we started at. When this line of code executes, when this instruction executes, it's going to change that register value to 0. And now it's set my timer, and it's going to go, hey, you ready to send something? I'm going to send it. And I'm actually going to try and turn off, I'm going to turn off channel 1 right here. And turn it to auto, all this other stuff. Yo, that was cool. Let me send something again. Single. Nothing going by. Nope. Single, 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 single. What's my channel settings? Oh, that's why. 1 millisecond. It should be like, let's do 0.01 milliseconds. Cool. Voltage, that's fine. Doing all that sort of fun stuff. Hopefully, if I do things right, then if I go like, come on, you're really not going to trigger? Fun times. So I'm going to swap real quick over to the digital analyzer again to see if I'm actually sending anything. So I'm going to swap from my oscilloscope. I swap pins over. I want to look at the logic analyzer. And if I hit run, go to my pattern generator and say single, am I actually getting the word 0? No. Oh, you know why? Because I have a breakpoint. Let's just keep the code running. Cool. Single. Am I just going crazy? I think I'm just going crazy. You know what? Let's just see if this works. And then I'll go into the debugging nightmare. So if I go over here and I say instead, let me send 1 and hit single. Hey, my LED turns on. How do I know? Let me go to my scope and turn on channel 1 again. And my time base, let me make it 1,000 microseconds. I'm too lazy to change it to anything else. Let me go to my trigger menu and change this to channel 1. Sure, falling edge. So there's my PWM. Let me open up this again. So let me send a 2. And then single. Hey, look, it stepped. And then a 3. Single. It's on all the time. If I send a 0, it goes back to 0. And if I go to like 3 again, it does that. So we've successfully made it. So every time I'm sending one of these characters, it's readjusting the PWM for you. Now, I am a little... At this point, you could basically turn off the video and say, yay, we did it. I kind of want to go a little further because I'm not incredibly satisfied with my results here. Something's up with my transmit. So I want to check that out real quick. I know we are at a half hour. That's cool. I basically want to stop my code the next time I get a UART byte. So I'm going to send the number, let's send 1. So at least it's different. So I'm going to say single. And now I've halted my processor. I want to come in here and look and see what I have. RX buff is equal to 31. TX buff is equal to 32. If I hit next, TX buff is set to 31. And that means if I look at my transmit line with that, with my digital 1, right, D1, I come over to my logic analyzer and make sure that I'm looking at digital 1 with any edge, 1 shot, number of samples, mega samples per second. And if it's running right now. So in theory, if I hit go and I get rid of my breakpoint, I should see something. Let me just run this. I think it's going to constantly send the number 1. Interesting. So it's not finding anything. let me turn off UART. So let me do a stream. I can't even find it. That's interesting. Turn off D0, turn on. Huh. Okay. Well, that's not showing up. I will do that in another. I will debug this and look at another video. In another video because this is taking so long. I really wanted to show you all. Maybe I'll see if the oscilloscope, if the pin is actually the thing that's the problem. Maybe the transmit pin wasn't set correctly. Let me go back here. We got RX and TX. 1.1 and 1.2. Did my code here accidentally blow out pin 1.2 again? Maybe. Yes, it did. Okay, don't turn off the video. Don't turn off the video. This is important. You are running into exactly problems that you will see when you just copy and paste things without just understanding what's happening. Did anybody catch the error? Look at our code here. First thing I do is when I configure the UART pins, I'm setting these pins to do these functions. With an equal sign, I'm doing a destructive assignment. Now what happens is as I come down here, I say, well, look, P-select2, that lovely thing that I just did here, nah, I'm just going to destructively assign it to 0. So we have to actually do a little bit of bit math here. So I need to do OR equals here because I want to make sure that these two pins are set correctly. So again, the problem is pin 1.2 was getting re-blown out. The select pin was getting blown out by another line of code here. So if I do OR equals, that's a non-destructive assignment. And I come here, if I wanted to do a non-destructive assignment here, it would be and equal not bit 6. Now, if I debug this and run it, hopefully it'll work. So, again, this comes to the power of, I can't stress this enough. If you all were to just sit there with your boards at home trying to do this, there is literally no way without a scope. I would even just say a scope. Come into labs to work. Without this, you are flying blind. I'm dead serious. You are flying blind. What I was able to figure out here and what you've heard me ramble on about was seeing, hey, everything worked except for my transmit. I needed to see what's going on. Even my oscilloscope is showing me that the pin is just locked. I'm not seeing anything. So something's up with my transmit. And I was able to go back and say, oh, wait a minute. Yeah, these are destructive. So now I don't have a, I'm pretty confident here that this will work. So let me run this. We got our PWM and hey, look. What the hell is happening up here, right? So now if you take a look at the purple channel, let me change my trigger to channel 2 so it locks in on that. I'm going to move this down here. So the orange is the PWM. Let's take a look at this as it lags. So this right here is the actual UART symbol coming on, or UART signal coming out of the processor. If you've spent too much time in the embedded world, as some of us might have, you could actually sort of read this as, you know, the right symbol. But seeing that you probably can't and seeing that you want this to be easier, instead of looking at an oscilloscope like this, instead we have this lovely thing called a logic analyzer that'll do this for us. So what I'm going to do is swap over to the logic analyzer now. I'm going to put in the logic analyzer pin. And hey, would you look at that? So the logic analyzer, essentially, it's sort of like what, it's an oscilloscope that's been discretized is one way to put it. So let me do one shot. And then I wonder if I can actually do trigger. Let me do auto mode. Trigger on, no, I don't want to do an external trigger. So let's do this. Right now it's just showing me the digital logic. 10110. Instead, if I double click on the channel, I can set up the channel to trigger on, let's say, a falling edge, rising edge to try and lock in on the signal. Instead, though, what if I go to the settings, and if you look, you can say available channels. Down here it says, hey, do you want to add a decoder? Do you want me to try and, do you want Scopy or your oscilloscope to try and decode this for you? And you can say yes, and look at all the protocols you can do. So I know that I've set my UART to 9600 baud. Let me set up my settings here, if I can, if it would let me. So I'm going to double click on UART. You see it's freaking out. It's like, oh, what am I doing? It's because when you initialize it, it thinks it's at a different baud rate. So it's reading all of these things wrong. So let me do 9600 baud. 8 bits. Okay, and would you look at that? Let me do single so it'll stop freaking out. Take a look. 31, 31. 31, 31, 31, 31, 31. It's pretty cool. So if I wanted to really show you like what the RX and what the TX are, the RX is going to be, so we are receiving on channel 1, and we are transmitting on channel 0. And if I hit run, cool. Now it actually runs. So there's a lot of cool stuff you can do with this. And all of this you can do at home with the ADALM. Or, while that's really good to work at home, I highly recommend that you take some time and you look at how to do it with the oscilloscopes in the lab. Because once again, before I turn this off finally, I cannot stress this enough. Look at the timer. This is 40-something minutes of video. And I mean, you just watched me ramble on and try to figure this out. I just hit a bunch of problems that you all will. Trying to combine just 2 example codes to get them to work, you really have to have kind of an understanding of what the processor or what the microcontroller is actually doing. And then you come back and you find, well, wait a minute, what happened? So let me recap. We merged the 2 things together, and the first issue that we ran into, I'm going to stop my debugging session here. The first issue that we ran into was I used double quotes instead of single, and that was my bad. I forgot that in C, double quotes is going to indicate that I want to use a string or a char array, and that a single quote indicates one character, which is represented as a byte, which can be cast into an int. So how we noticed that was in the debug, we used the step function. So we used a breakpoint to say, hey, next time I send a character, stop, I want to step through this. And we said, hey, look, okay, our value is getting set, but now it should have been a 0, but it wasn't. Receiving, it never matched these, so it skipped forward. So we were able to determine that using the tools built into the debug pane. Then we said, okay, we fixed that, and hey, look, the PWM works great. We're ready to be done, right? No. Why? The transmit isn't working. At the end here, I said, you know what? Let's just transmit what character we sent just for a sanity check, and it was never doing that. Using the register thing, we were able to say, hey, look, the register's getting sent to the right value. The TX buffer is getting set to the right value, but it's never sending. And what we did was we started going back to look at the UART code and saying, well, UART pins are configured to the select bits are 1 and 2, right? But then we do this configure LED pins, and in that code we had what I would consider to be a destructive assignment. Destructive assignments aren't bad, they're useful. But what happened was we said, hey, look, we took all this time and care in one of the instructions to actually take this and set it equal to a value. And then we said, hey, just set it equal to 0 at the end of the day. So up here, we spent some time to set select 2 to some numbers. And then down here, we had to fix this to say, hey, I want to non-destructively assign pin 1.6 to be the timer. And I want to keep pins 1.1 and 1.2 to be the same value. So hopefully this gave you kind of a little bit of insight into how to do this. And is everything going to take 45 minutes? I don't know. It depends on what bugs you run into. And again, the best thing that you can have in front of you is a scope. It lets you see the invisible. Where I would like to see you take this, if you can muster the effort, expand this out. Do more. See if you can maybe figure out how to do a bunch of different things, more than 10. Maybe control the RGB LED instead. See if you can possibly do that. Change the duty cycle or the PWM to be done from a software perspective. There's a bunch of different ways to do that. And I would also argue that you should look at how to turn this into functions. Is it the world's most efficient way of programming? Depends on your compiler. But what it does is it makes it where instead of relying on all of this, you literally have code that says configure UART, configure LED, and you can isolate the problem out. So with that, I hope this wasn't a complete waste of your time, but again, I think there's a lot of insight to be had into watching someone go through like the process of here's the plan, here's what we want to do. So yeah, I hope this was helpful.